All right, everybody, welcome to the video here for lesson number 8. I know it says lesson 7. It's a typo. It's actually lesson number 8. So lesson number 8 was on kind of working with complex solutions. So we're going to wind up having like some quadratic formula questions. We worked with this new thing called the discriminant, and we're able to solve some things here. So for the first question, it says use the discriminant to predict the number of solutions you have. So you could graph this and figure it out, but let's use the discriminant instead this time, just seeing that there is a different way of doing it. So remember, the discriminant is b squared minus 4ac. So I have negative 4 squared minus 4 times 5 times 3. If I type that into my calculator, right, remember when you square a negative, it becomes a positive number, right? So I have 16 minus 60, so I have negative 44. Since this is negative, I know I'm going to have two complex solutions. Although it didn't ask me, it also tells me that I would have no x-intercept. There's a lot of other things that we could do here. So then it says to solve the equation above. So for that, I'm going to plug into the full quadratic formula. So negative of negative 4 is positive 4, plus or minus the square root of 44, all over 2 times 5, so 10. Remember, all of these we're going to separate. So I have 4/10 plus or minus the square root of negative 44 over 10. Square root of 44, well, I could break that down to the square root of 4 times the square root of 11. So that would be 2 square roots of 11. So I could really rewrite this as 2/5 plus or minus 2i square root of 11 over 10. Still can be simplified. Final answer here would be 2/5 plus or minus I square root of 11 over 5. Number 3 says to solve the equation. So to be able to solve these, you have to move everything to one side. So I got to move that 9. So I can add it to the other side. So if I do the discriminant here, I'm going to have 8 squared minus 4 times 2 times 9. Right, so 64 minus 72, so negative 8. So I know I'm going to have two complex solutions again. So I'm going to have x equals negative 8 plus or minus the square root of negative 8 all over 4. Square root of negative 8, so square root of 8 becomes 2 square roots of 2, because that's going to be 4 times 2. So that's going to become x equals negative 8 over 4 plus or minus 2i square roots of 2 over 4. Simplify. So I have negative 2 plus or minus I square roots of 2 over 2. So notice here we have two things that are simplifying differently, right? So 8 over 2 reduces to have a denominator of 1. The second fraction here has a denominator of 2. So if I didn't separate, I wouldn't get those answers in simplest form, which is why you separate. Number 4, put this right order, get it equal to 0, we get that. All right, so I'm going to subtract the x to the other side. Discriminant first, so I have negative 1 squared minus 4 times 3 times 1. So I have 1 minus 12, so negative 11. And because we have negative 11 there, we now know, again, two complex solutions. So I could say x is equal to 1 plus or minus the square root of negative 11 all over 6. So then I can rewrite that as two separate fractions, 1/6 plus or minus I square root of 11 over 6. Square root of 11 can't be simplified, so I'm done. That actually was an easier one compared to the others. Number 5, algebraically solve the system. Oh no, this is something different, but similar. So we've done this before. We've done this when we were in the first 2 lessons of this chapter, but now we can solve these two and not necessarily find the points of intersection, but find the solution when there is no points of intersection, right? So I could set them equal to each other. So x squared minus 4 equals negative x minus 5. Now, if I graph that, so let's just think about what the graph of that looks like for a minute. I'm just going to do a quick sketch here. So here is your x squared minus 4 graph, and negative x minus 5 is going to look like this. So if you were to graph those both on your graphing calculator, you're going to get two things that never intersect each other. So if I add all this stuff to the same side, so I have x squared plus x plus 1 equals 0, not factorable, right? If we do discriminant, so I have 1 squared minus 4 times 1, that's negative 3. Two complex solutions. So I'm going to say x is equal to negative 1 plus or minus the square root of negative 3 all over 2, or negative 1/2 plus or minus I squared roots of 3 over 2, which would be the best possible way to show the answer. It's in a plus bi form. There you go. Right, verify there's no solutions graphically. I just did that over here, right? You could do that right in your calculator. Just say they have no intersection points, right? Other than that, good luck. Remember, after this lesson, you will have a quick quiz coming up, maybe even 2 quick quizzes coming up. There's a lot of things that we've learned here over the last few lessons dealing with all of this stuff. So good luck studying, all right? And I'll see you all next time we have school.